available to other people who aren't at this event just now. And just to say also, I'm not in any way connected to an air source heat pump supplier or installer. I'm just, myself and Claire have got one installed, so we're just sharing our views on the technology and the installation costs and grants process and pros and cons. So let's move forward. Great. So first of all, the technology, and what you can see on the right there in the view, incidentally, is the tank that goes in your loft. So it's just like the tank you would have associated with a normal gas boiler, where it's heating up a tank of hot water. So fairly similar. Ours is about 1.2, 1.3 meters high, and it'll take up to 170 liters. But the key thing about an air source heat pump and why it's so much better than a gas boiler is that it's 4 times more efficient than a gas boiler. So a gas boiler, an A+ one, is typically sort of 80 to 90% efficient at converting the energy in the gas into energy as heat. Conversely, 1 or 2 more people are still joining us, that's lovely, thank you. Conversely, an air source heat pump is up to 360% efficient, so well north of 100% efficient. And the reason for that is that it doesn't generate heat, it just moves heat from one place to another. And so when you power it using electricity from renewables, it really does hugely reduce your carbon footprint, because you're not burning any gas at all, you're not creating any emissions, and in fact the electricity you are using is coming from photovoltaics or solar or other renewable sources. And it can heat both the hot water and the central heating. And as I mentioned, it does need a tank, and it's not a like-for-like replacement for a combi boiler. You do need a tank as well. So I'm going to stop sharing and share a separate screen, which is a video, just to give you an indication of what the excuse me, I think that's the wrong screen. So whoops. Right, could people just put a thumb up if they can see that? How does an air source heat pump work? Great, thank you very much. Lovely. So I am going to. Sorry, forgot to say share sound, so I'm going to share sound as well. And there we are. So I'm going to play this. I'm only going to run it for sort of 30, 40 seconds, but I'll stop it and give a bit more background into how the technology works.
How does an air source heat pump work? Air source heat pumps are an efficient way to heat up your home, but do you know how they actually work? In this video, we'll break down the process into simple terms. An air source heat pump works a lot like a refrigerator, but in reverse. Simply put, it draws in air from the outside, heats it up, then uses that to warm up your home. How it actually does that depends on which type of air source heat pump you have, an air-to-water heat pump or an air-to-air heat pump. An air-to-water heat pump takes the heat from the outside air and transfers it to a coolant. The coolant is then pushed through to a hot water reserve tank via a heat exchanger. From there, the hot water is circulated into the wet central heating system in your home, such as your showers, faucets, radiators, or underfloor heating.
Right, so we've got there a diagram of the air source heat pump, and you can see outside the building is this device here, which is a heat exchanger, and inside the building here is the hot water tank image I've showed you already. So what happens is that refrigerant gets moved around this circuit. Now, the refrigerant is a liquid that boils at a very low rate, and when it's at this place in the unit on the outside, it's actually allowed to boil. And so by boiling, moving from a liquid to a vapor, it takes heat out of the environment. And that's just the same as putting water on your hand. If you put water on your hand feels cold, and that's not simply because of the cold of the water. It's because when the water on your hand evaporates, it actually requires heat or energy to move from a liquid state to a gaseous state. And that takes out heat. And so exactly the same thing happens at this part in the unit on the outside of the building. The refrigerant boils and that pulls heat out. And that is key to the way these work, because it is possible to transfer heat from the outside of the house into the tank, even though the outside is a lot colder. So, for example, it will work quite happily down to -15 degrees, because it's still able to boil the refrigerant and thereby absorb from the outside. So now I'm going to stop sharing to my PowerPoint again, and back again. It produces water. That's a picture of the outside, by the way, there. It circulates about 55 to 60 degrees centigrade. Could I ask everybody to mute, please, just so that people can hear? Thank you very much. The water circulates at about 55 to 60 degrees, so that's a lower temperature than a gas boiler. Gas boilers will heat the water quite a bit higher. So it may well need larger radiators. And when we had ours installed, we actually needed to replace 7 out of the 11 radiators. If you do have underfloor heating, then that's also an option. That has quite a large surface area, so it delivers the same benefits of having a larger radiator. And those larger radiators are simply needed because the water is at a lower temperature, so you need a bigger surface area to heat the individual rooms. It also needs a reasonably well insulated house, and that means double glazing and an insulated loft. As I mentioned already, it can work even down to -15 degrees centigrade outside temperature. And testimony to that is the fact that something like 1/3 of all homes in Finland are actually heated by air source heat pumps. I'm sorry, there's somebody, I think, still got a not on mute.
It's Claire. Claire is not muted.
Claire is not muted. Claire, could you mute yourself, please? Thank you. As I say, about 1/3 of all units, 1/3 of all houses in Finland are even heated using air source heat pumps. So that big unit there must be outside the house, because that's where the heat is that you're moving into the house. And it usually doesn't need planning permission. The face of the unit must be at least 1 meter from your boundary. And that's understandable, because actually it blows out cold air, because that's the heat exchanger in action. So blowing cold air onto your neighbor might be considered not a very nice thing to do. So face of the unit at least 1 meter from the boundary, and our unit's roughly about 80 centimeters by 80 centimeters by 40 centimeters. So it's not a huge device, but it's reasonably chunky, and it can be wall mounted or freestanding, depending on what space you have available around the house. And probably freestanding is better than wall mounted if that's possible, simply because it's slightly less work involved in the installation. So moving on a bit more about the technology, we've got 3 sets of controls. There's a wall-mounted programmer, and that's the image you see there, which allows you to program it in detail. There's an app, and also there's a wireless zone controller, and that is the one that we use most of the time, and all it simply allows you to do is toggle the temperature up or toggle the temperature down. But the combination of all 3 does seem to be quite effective. And one of the things that's remarkably surprising is it's very quiet. And we were told it would be 55 decibels. And to be honest, I don't know what 55 decibels sounds like. We'd been told that it was about the same as an electric toothbrush. And honestly, when you walk past it, and ours is wall mounted, so it's at, it's probably sitting at about 2.5 meters, it's almost inaudible. You can just be aware that it is operating. And importantly, because it's a health and safety issue, it runs through an automated Legionella heating cycle every 2 weeks, which heats up to, I think it's 65 to 70 degrees, to make sure that any trace of bugs are killed in plenty of time. And it does that automatically. You don't need to program it at all. It just happens. So moving on, that's the technology. Let's look at the installation costs and the grants. So our total costs were just shy of £15,000. That includes VAT at 2.5%, a reduced VAT rate to encourage more people to do this. And importantly, there are 2 government grants available, and they're linked in some way. The first is the Renewable Heat Incentive, the RHI scheme, and the second is the Metering and Monitoring Service Package, MMSP. We applied for and got both, and importantly, both are still operating at the moment. It's not associated with that Green Homes grant that the government launched with great gusto about a year ago and then killed after 6 to 8 months because it wasn't working properly. These ones are both still operating, and importantly, they're not means tested either. So they don't look at your earnings, they just look at whether you've installed the technology and installed it correctly. And the total grant that we're getting back is about £13,500. However, the sting is the payments. You don't actually get that £13,500 back in a chunk. It's spread over 7 years. So you do have to have the initial capital available to make this happen. Although there are bank loans available, and in fact, the particular installer we used also used a bank that I'd never heard of before, but called Icano Bank, which is actually a bank owned by IKEA. And it was a reasonably low interest rate, so that would have been possible for those who aren't able to finance it from their own resources. And certainly when it comes to the grants, the installer helps with the application process. It was fairly straightforward to us. It was done online. I would say it took about 15 to 20 minutes total to make both applications, and we heard within 3 to 4 weeks of making the application. Just a point to note though, you don't hear if you've been successful until after you've installed the equipment, which is a bit mean. It would be better for people to know that they've got it. Although, to be honest, I don't think there would be any reason why anyone wouldn't get it, because the process is intended to make sure that you're successful before you apply. And importantly, it's only used for air to water source heat pumps, not for air-to-air source heat pumps. And air-to-air source heat pumps are those sorts of units that you typically get in offices or hotel rooms that can work as air conditioning units as well, that can produce cold air during the summer and warm air during the winter. Now, air conditioning is a problem. It's very energy intensive, and so it would not be right, clearly, to be financing and encouraging individuals to implement air conditioning. And actually, it's one of the problems of the climate crisis, and it's one of the horrible feedback loops that as the planet gets warmer and we all get hotter, more air conditioning is installed, and that in turn produces more carbon dioxide, which heats up the planet. It's not a nice situation to be in. The other cost to mention is annual service costs of about £120, and that is a requirement of getting the grant over the 7 years, is that you keep having an annual service. And that makes sense because obviously it's checking that the system is in tip-top condition. So what's the process? Well, we sort of found an organisation, an installer. We had a visit from their sales rep, actually somebody who was reasonably knowledgeable, came across as being quite sort of aware of the technology and how it all worked. He then arranged for an independent renewable heat incentive survey. Now, this is the check to make sure that you would be eligible for the grant before you apply for it. And that RHI survey checks that the insulation in your house is adequate. It also checks the proposed location. Well, welcome, new person who's just joined. Could I ask you to mute yourself, please? Thank you very much. So the RHI survey checks the proposed unit location, make sure that there's not going to be any planning issues. Also issues an energy performance certificate. And just to let you know, I was surprised at this. We were actually D, and I thought we'd done quite well with our house, but we were lower than I'd anticipated. And I think that's partly because they do occasionally rescale these types of approaches, the energy performance certificate, to encourage people to progressively insulate their houses to a higher level. And that independent RHI survey is needed to access the grant. Without it, you don't get the grant. But once you've got it, access to the grant does seem very likely. And it does cost £150, so that is an upfront payment you have to make before you hear back. Hello again. If you could mute yourself, that would be great. Thank you very much. Thanks. And so after we'd had the visit from the sales rep, we then got a formal proposal through from the contractor, and that included a radiator schedule and a financial projection. So the radiator schedule told us exactly which radiators were going to be changed and which ones we could keep. And the financial projection was based on modelling that assumed the outside was always minus 2.7 degrees, and I think the inside was 20 or 21 degrees, so not an expected type of conditions in St Albans for much of the time, and so it did imply that we were going to spend more than we're actually spending. But I guess that's a safety net. It means people are aware of the worst case rather than a reasonable case, perhaps. And the lead time was about 4 to 6 weeks from saying yes, please, to it being installed. So what are the pros and cons? Well, the unit we got, and you can see it on the side of the house there, was installed in one day, and it's got a 5-year guarantee. In fact, we didn't really like the way it looked, so actually I put a small lattice fence around it just to slightly conceal it from the from view. In fact, as you can see to the left of the unit, there are some doves in our dovecot that are sitting there quite happily, so they are clearly not phased by the 55 decibels electric toothbrush of the air source heat pump. And installed it in one day was good. I've got to be honest and say the installers we used felt like they rushed it a bit, but and as a result they're having to come back and correct 1 or 2 things. But it wasn't a long and involved process. The heat is gentler than a gas boiler. You know, when you walk past a radiator when it's being heated with gas, you really feel the heat coming off the radiator. You don't get that with an air source heat pump. You just become aware that the room is warmer. You're not aware of the source of the heat. And because the circulating liquid is at 55 to 60 degrees, it is undoubtedly slower to heat up the house, so it's less immediately controllable. As a consequence of that, the maximum efficiency is to keep it on for longer periods. So when we were using gas, we used to what they call apparently pulse heat. So we would have it on for about an hour in the morning to warm up the house, and then in the evening for about 3 or 4 hours, from 6 to 5 till 9, something like that. Instead, with this, we've been keeping it on for most of the time. Now that means obviously we're heating the house for something like 15 hours versus 5 or 6 hours. But the running costs are nevertheless similar to gas. So we're in some ways getting, or have been until now, obviously, more benefits in terms of a warmer house for longer periods, which actually has suited us, particularly given the fact that we're both working from home. The controls are a little clunky. They're not as quite as polished as the ones you might get with a gas boiler. Took me a little longer to learn how to use them, but I'm comfortable with them now, and they certainly do the job. And as I mentioned, the unit isn't perhaps the most attractive, which is why we put that lattice fence around the unit. So those are many of the pros and cons, but perhaps the biggest one, in fact, the biggest one for us, is the huge carbon footprint reduction. And so because we're not using any gas at all, other than for cooking, which is a tiny amount, our gas consumption has absolutely plummeted. And that gas obviously produces CO2, whereas we're using electricity from renewable sources. Our renewable electricity supplier is a company called Bulb. And I understand Octopus are also quite a good one as well. And I looked to try to calculate the carbon footprint reduction. I found two different methods, and they've come up with slightly different numbers. One was about 2.1 tons and the other was 2.6 tons. So perhaps it's better to say it's somewhere between 2.1 and 2.6 tons of carbon footprint reduction. And for us, that was the biggest reason for doing this. We are, both of us, very worried about the climate crisis. We think, and we think far more needs to be done than is being done at the moment. And just for example, for the government to be able to meet its current targets, there has to be a massive increase in the installation of air source heat pumps. And yet I don't see any effort from the government to really promote their use and implementation and uptake. So those were the main pros and cons for us. That's the end of the presentation. I'm going to stop sharing my screen, and I'd love to hear of any questions or thoughts people have.
Could I, thanks Nigel, that's a very good talk. Can you hear me?
Yes, can indeed, please fire away.
The costs, I wasn't quite clear about your costs. First of all, you mentioned something around 14K for the installation. And then secondly, you say there's 13K as a grant. So you get that, you pay out initially 14K to get the thing installed. And then over a 7-year period, you get 13K back.
That's correct, Julian. That's the way it works. And in fact, I should point out that it was 15K actually. The 15K installation costs included installation, the unit, the radiators, everything. That was all in. Having shelled that out, we will get about 13.5K back over the next 7 years.
So after 7 years, the installation...
No. Over the course of 7 years, it's spread more or less equally over the 7 years.
Okay.
So about just shy of £2,000 a year over 7 years.
So after the end of that 7-year period, your pump really has only cost you the difference between the grant and the amount you shelled out initially.
Correct. That's right. And if you were to try to build in interest costs, that would be diddly squat at the moment. So yes, it is broadly the difference between the 15K and the 13.5K.
That's quite a good grant, really, isn't it? I suppose.
It is a good grant, except that it only works for those people who've got the money already. Yes. And that's maybe perhaps not the best way of designing a grant if you really want to get lots of uptake. Yes. I see. I had a question from Caroline Wilkins saying, how long before you need to replace the unit? This is, this is a tried and trusted technology. It's actually been around really for quite a long time. It's actually the same as a fridge. It's a fridge in reverse, and it's air conditioning systems as well. So I don't know what the typical lifetime is, but actually it wouldn't surprise me if they're longer than a gas boiler, because there's arguably less to go wrong. I see there's another question from Jane Dowden. How does it compare to a ground source heat pump? We didn't, it's a good question. We didn't think about just to go for a ground source heat pump because it requires quite a lot of space, and it is definitely more intrusive. And also, we've already got a patio around the house, so that would have had to have been dug up. The costs are quite a bit more than an air source heat pump as well. Although they are meant to be also more efficient, because the ground has heat that is more stable and predictable. So whereas the outdoor temperature here was, about 8 weeks ago, hard to remember, but it was about -3 degrees. Whereas the ground is consistently at a temperature that's quite a bit higher. So they are more efficient, but quite a lot more involved to install. I think that's all the questions in the chat at the moment. Any other questions anyone would like to ask? Peter Berners-Lee.
Hi, great presentation, Nigel. Thank you very much.
Thank you. Could you come towards your unit slightly or speak up? Thank you.
Sure. Your diagram showed 2 tanks. Looked like you had the ordinary water tank, but also another tank acting as a heat exchanger. Does that mean you have to have extra room inside the house for this setup?
So we've got the unit on the outside. Inside, all we've got is the tank, which is both the exchanger and the sort of a heat exchanger in coil inside the tank and the water tank combined. So that unit, as I mentioned, is about 1.2 meters tall and probably about 45 centimeters wide. There is also a pump beside it, and that pump is probably 40 centimeters high and 30 centimeters wide. And there's a few other bits and bobs in terms of controls, but no, it shouldn't take up much more space than you've got at the moment.
Great, thank you very much.
Catherine Ross.
Thank you very much. That was really clear. Can you tell me more about the radiators? Because that's one of the bits that troubles me. So did the actual radiators have to be bigger, or is it are they somehow got a higher surface area and a different design that fits in the same space on the wall?
It's actually a bit of both, Catherine. So the radiators, some of the radiators are deeper. They have different specifications. This is something called K2, which is, I suppose, about 15 to 20 centimeters deep. And then there's a deeper one still, there is K3, that is more about sort of, well, closer to 20 centimeters deep. So you can get quite deep radiators. Most of the time we didn't go for the deep ones because it take up quite a lot of space sticking into the house, into the room. And instead we went for radiators that were just a bit longer. So one way or another, you do need more surface area in the radiators. Great, Martin, and then Nigel.
Hello, can you hear me all right?
Yes, thank you, far away.
Hello, thank you for the presentation. I noticed you said that the circulating water is about 55–60 degrees in the system. So I was wondering, when you need water more heated than that, do you have taps that have self-boiling taps then if you need higher temperature? How does that work when you need more hot water than 50–60 degrees?
To be honest, we don't need more hot water than what the unit is capable of delivering at the moment. It certainly produces a shower that would be too hot to stay in if we turned it up to maximum. No, we don't have self-boiling taps or anything like that. And you can specify the size of water tank you need. I think I mentioned ours is a 170-litre tank. And obviously you can presumably get larger ones and smaller ones. And incidentally, while I'm on that, also the outdoor unit, ours was specified at being 11 kilowatts. That's 11 kilowatts of heat output, whereas the electricity taken in is more about 3 kilowatts, which gives you your 360-degree efficiency. You've got 3 kilowatts of electricity in to get about 11 kilowatts of electricity out. But no, there is lashings of hot water, and we don't need to do anything beyond what we've got at the moment.
Okay, great, thank you.
Nigel Quinton.
Yeah, thanks, Nigel. Sorry about the not being on mute at the beginning. Yeah, very interesting talk. Thanks ever so much. A couple of questions really about the costs of getting it installed. What was the split between, or how much was the actual air source heat pump as a proportion of your 14,000? That's the first question.
I don't know. We got one price at the bottom, basically. Or I think actually for the purposes of the grant, they said, right, say this much is installation, this much is units. But I think that was for the purposes of the grant. So whether that represented reality is probably not the case.
Okay, and I suppose the other question, you may well not know the answer to this, but can you combine it with other forms of heating? I mean, could you put in an air source heat pump but keep your gas boiler to top up when necessary? So you reduce your gas usage, but you've got that flexibility.
I don't know whether you'd be eligible for the RHI grant if you were to.
Right.
Let's remember this is about carbon footprint reduction.
Yeah, I know, but I'm thinking you'd still reduce your carbon footprint. But if you,
yes.
So we've got an old house, as I expect quite a few people in the call have, living in this part of the world, and the insulation is, although we've done as much as we can, for conservation reasons, we can't get double glazing on every window. We've got it where we can, but not on some. So, we're in inherently a leaky house. So when we've looked at this in the past, we've tried to sort of, would it be sufficient, or how many, we really have to beef up the radiators if we went for this on its own. So I'll take that question away and ask, and maybe call a contractor.
Right, okay. What it can be combined with is solar PV for hot water, solar hot water.
So thermal, yes.
It's even more efficient, indeed. I noticed there's a couple of more questions in the chat. Sarah saying, do you know the likelihood of getting permission to install these kind of units within the St Albans conservation area? I honestly don't know the answer to that question. And just because the RHI system told me that we didn't need planning permission, that might be different in a conservation area or a listed building, even more so. How much chaos, Harriet asks, in the house to install upstairs bathroom? Well, it was a day, and that's the saving grace. Yes, it was quite a bit of chaos. They were in, they had to replace 7 out of 11 radiators, so they were in most of the rooms of the house during the course of the day, and it was a bit stressful while it happened, but it happened, and we got sorted out the next day and the day after. So it wasn't too intrusive. A comment here from Hillary: refrigerants can be powerful warming gases. Absolutely, they are. Many times worse than CO2 if it leaks. And did we consider this? Well, no, we didn't, because it's tried and tested technology, and all of us have refrigerants in our fridges and freezers, and they're pretty good at containing those refrigerants. The one thing I would advise, actually, and this is from my work experience, is whatever you do, if you want to get rid of your fridge or freezer, don't leave it on the doorstep, because someone will come and take it away. But what they do when they take it away is they clip off the compressor that is copper and valuable. That releases all those refrigerants to the atmosphere, and then they leave the carcass for someone else to sort out. So yes, refrigerants are dangerously warming gases, but the system is tried and tested, and I've not heard of any incidences of leakages. Caroline Penn asking, can you comment on the risk of refrigerant leaks? I think I've just explained that. How many kilowatt hours of electricity does the unit use? As I mentioned, it's about it's rated about 3 kilowatts input for 11 kilowatts output. Catherine, I see you've raised your hand.
Yeah, if it's okay to have another question.
Please do.
Have you had it yet through a cold winter? And does it cope okay on the coldest odd days, or do you have to have any top up electric heaters or something around the house to cope with the really cold days?
Well, that sort of 6 to 8 weeks ago, when it was -3 outside, it was toasty warm, sort of plus 20 degrees or so inside. So no, we didn't need to switch on extra heaters. It was absolutely fine. And as I say, if you think about the climate in Finland, I'm sure that the people in Finland are also have warm houses at sort of 20+ degrees, even though it'll be considerably colder than -3. So far so good. It's been absolutely fine, toasty warm. I see somebody's asking, oh, there's a black chimney beside on the side of our, yes, that's a chimney from a separate heating appliance. That we don't need to use that to be able to add secondary heating. We've basically, the unit will provide us all the heating that we need. Caroline Penn. You're on mute, Caroline, if you could unmute yourself.
Sorry, I just thought I'd mention, whilst you're on the subject of insulation, that people know about the sustainable St Albans thermal imaging camera, which you can borrow in the winter season to check out your leaks and missing insulation before you do have a survey done. For the renewable heat initiative. But I wondered if you could also comment a bit on the Legionella heating cycle and what happens if you turn off the system, you say you're on holiday or something like that.
I think even if we turn the system off, I understand it will go through the Legionella cycle because it's a health and safety issue once every 2 weeks. I mean, I guess if we were going to be away for several months, I might contact the company and say, hang on, what should we do? But we're away for a maximum of 2 weeks any point in time, so it's not too much of an issue. And in fact, we've got a smart meter, and I noticed when it's gone through one of those Legionella cycles, it's cost about 80p, 70p of electricity to go through that process. So it's not a killer.
Thank you.
Jane is asking, find a list of companies that are recognized installers. To be honest, I Googled it, and then I found a company that would sort of send one request out to multiple installers to get in contact with us. And I think that was an organization called Green Match, which was the name on the video that I shared at the beginning. Dennis asking, I don't understand how you can get 11 kilowatt out, 3 kilowatt in. And this is not possible. You're right, it's not possible if you were heating the water, but an air source heat pump doesn't heat the water. It just transfers the heat from the outside of the house to the inside of the house. And so that's why you're able to get effective efficiencies of 300 and 350% or so, because you're not actually using the energy to heat the water, you're just using the energy to transfer the heat. I see there are one. If anyone has asked a question in the chat, but I haven't answered it, do shout out. So here's a question from Chris Evans saying, do you know if you need to meet a certain home efficiency band to qualify for the grant? I don't know the answer to that. Obviously, we came out at being band D in our energy performance certificate, which, as I said, I was surprised at. I was expecting us to be higher than that. So I sort of pride myself on doing the insulation properly. So I was a bit deflated when I saw that. So I presume if you're at least D, then you should be okay. But clearly, it's the renewable heat installer independent audit and check that will verify that, and that would be the way to check that. And a question from Elizabeth George, are the heat pumps noisy? Do we get complaints from the neighbours? It is whisper quiet. It really is whisper quiet. When you walk past it, if you stop, you can probably hear it, but it is not noisy at all. And so no, there's been no comments from neighbours at all. It's barely audible. Does it heat and cool, asks Dennis. No, it doesn't. And the renewable heat incentive doesn't allow for units that produce both heating and cooling, because that would be an inefficient use of electricity and therefore wouldn't be subsidized as a way of reducing the country's carbon footprint. So no, an air to water source heat pump only heats, it doesn't cool. Any other questions? I think I've answered all the ones in the chat now. Sarah, really interesting. I live in a flat, so don't have the space now, but hoping to move. Great. Well, good luck with the move in that case. Anyone else? Any other questions that you'd like to ask? Martin, fire away.
Hello, can you hear me? All right.
Yes, thank you.
Good, thank you. So I also live in a flat. I'm just wondering, rather than each of the 16 flats having 16 separate air source heat pumps outside, whether there's sort of one larger option that could do for a block of flats if several flats wanted to go and adopt this technology all at the same time. If you know, having 16 separate units out the back would take up quite a lot of room. If there was a one unit version that could do more than one flat, that would be really useful.
I think you're right, it would make a huge amount of sense. I don't know whether the grant system has yet drilled into that level of subtlety and sophistication, because it would make huge sense. And indeed, with new builds as well, there is no reason why a new housing estate couldn't be built in such a way that ground source heat pumps are installed right from the beginning, possibly with some sort of shared infrastructure. So, you know, one unit is serving multiple properties. And this I think is the sort of things that the government really should be getting their act over if we have any chance of hitting the targets that have been set. But sorry, no, I don't know the answer on the flats.
Okay, thank you. Thanks.
Thanks. Caroline, on the subject of the carbon footprint reduction, you could take some action, take a look at the count. What are you meaning there, Caroline?
Sorry, my finger slipped. I meant to put it in towards the very end. It was just whilst we were talking about carbon footprint reduction, there is an initiative called Count Us In, where you can look at steps to take to lower your own carbon footprint. Obviously, this is one very big step to be taking on the energy section of this. So that's something, but there are other steps as well, like moving to green energy suppliers and many other things.
Indeed,
sorry, I meant to put that in towards the end.
Not at all. Yeah, but yes.
Can I just ask one more thing, actually?
Yeah.
That I'm not sure if you answered the question, how long does it take up to actually heat up the house from, say, a cold? There's somebody put it in there in the chat.
Yes, they did. I mean, I've been wondering that myself, because if we haven't yet gone away on holiday and arranged to come back, in January, having been away for a week when I would obviously switch it off. So don't know how long it would take to warm up the house before that happened. But actually there is a holiday scheduler. So you basically use the app to say, right, I'm going away on Sunday, coming back on the following Thursday. Please could you switch on Thursday morning? So whilst it would undoubtedly take longer, there is no reason why you shouldn't be able to come back to a warm house. I guess if on the spur of the moment, you end up coming back on the Wednesday, not on the Thursday, it might take several hours to heat up. That's quite possible. I know Deborah Atkins saying, notice your appliances are still using gas. Yes, we are still cooking with gas. And what has surprised me is how little gas we use for cooking, partly because we've got a smart meter now, but the cooking is the only source of gas. In fact, it's only the hob. The oven is electric, and the hob is gas. But our daily charge, I think, standing charge is 25p, and we're typically spending between 1 and 4p on cooking with gas per day. So the amount of gas we're using is a vanishingly small proportion of the amount we were using when we were using a gas boiler. Now somebody's putting some useful information here, so I can't see who it is, but oh, Catherine Ross, thank you, Catherine. I think it's right that the renewable heat incentive closes to new applications March next year to be replaced by the less generous clean heat grant, expected to be worth 4K. So worth looking into it sooner rather than later. Thank you, Catherine. That is a very useful tip for anybody who's considering this. Clearly, there is still time to do it, but March next year will come around remarkably quickly. Thank you. And just to finish the question about the cooking, no, we're not planning to move completely off grid, given that the amount of gas we're using for cooking is so small. No, that's not anything we're planning. Caroline, did you just put your hand up again, or was that?
It was me pretending to be Caroline.
Hi, Simon. Right. Okay. Fire away.
You ended up with your external unit in what looks like quite an awkward position. I just wondered why. Was there any particular reason why it was there, or was that dictated by something?
To be honest, we didn't want to put it on the ground because there was no easy place that we could put it on the ground and still allow a car. Sorry, we haven't got rid of our car yet. Mea culpa. To be able to pull up in front of the garage. So we decided to hang it from the side of the wall. With hindsight, perhaps we could have been able to just put it on top of the flat roof of the garage, which I think you saw there, which was the flat roof on which that trellis fence has now been placed. So that probably would have been quite possible. We weren't sure how firm that garage roof might be, so we preferred to hang it from the wall. But actually, given the fact that they parked the unit on there before they hung it on the wall, it was probably it would probably. So
now you know it's safe enough anyway.
Exactly.
So there's nothing about the unit itself which forces it to be in a particular position with the kind of infrastructure of the house or anything?
No, and we could quite happily have had it on the ground with, there are two pipes in enclosed insulation that go from the unit up the side of the wall and into the loft where the tank is. Although we've got a run from just above the garage to the loft, it would have been equally fine to have that from the ground to the loft.
Okay, all right, thanks very much.
Any other questions? Great. In that case, I think that probably brings us to a close. Jane saying thank you, and thank you everybody for coming along. I hope it's been useful, and I would encourage people to have a look at this because it's so important, and it's one of the ways, along with going vegan, stopping air travel, that can really make a massive difference to our carbon footprint. So thank you very much, everybody, and goodbye. Thank you. Bye-bye.